The universe is hiding 50 mind-blowing secrets from us, and today we're cracking them wide open. Picture this: somewhere out there, an invisible force is pulling entire galaxies toward it like a cosmic magnet. Elsewhere, particles communicate instantly across billions of light years, defying everything we know about physics. And that's just the beginning. From mysterious radio signals that vanished without a trace to black holes that might be shredding the very fabric of reality, the cosmos is packed with puzzles even scientists can't fully explain. But here's the wild part: we're about to uncover them together. Over the next few minutes, we'll dive into 50 of the universe's most jaw-dropping enigmas, secrets so strange they'll make you question everything you thought you knew about space. So buckle up, this isn't just a video. It's a front-row ticket to the greatest mysteries the universe has been keeping from us. And trust me, by the end, you'll never look at the night sky the same way again. Ready? Let's go. Now, let's zoom in on our first cosmic mystery, the Great Attractor. Imagine a force so powerful it's dragging entire galaxies, including our own Milky Way, toward it at over 1 million miles per hour. Yet, here's the twist: we can't even see what's doing the pulling. Hidden behind the dense stars of our galaxy's center, this gravitational monster lies about 250 million light-years away in the direction of the constellations Centaurus and Hydra. Scientists call it the Great Attractor because, well, it's literally attracting everything around it. But what exactly is it? Some think it could be a massive cluster of galaxies, while others speculate it might be something even stranger, a colossal concentration of dark matter. The problem: our view is blocked by the Milky Way's own dust and stars, making it like trying to spot a flashlight through fog. Even with advanced telescopes, this region remains one of the most frustrating blind spots in astronomy. So while we're hurtling toward it at breakneck speed, the Great Attractor keeps its secrets locked away, reminding us just how much of the universe is still waiting to be uncovered. And this is just the first stop on our journey. Trust me, it gets even weirder from here. Now, let's turn our attention to something even more elusive: dark matter. Picture the universe as a grand cosmic dance, with galaxies swirling and stars moving in perfect harmony. But here's the catch: what we see isn't the whole story. In fact, the visible matter, the stars, planets, and gas, makes up less than 20% of the universe's total mass. The rest, that's where dark matter comes in. This mysterious substance doesn't emit, absorb, or reflect light, making it completely invisible to our telescopes. Yet its presence is undeniable. How? Because of its gravitational grip. Dark matter's pull is what keeps galaxies from flying apart as they spin. Without it, stars on the outer edges of galaxies would move much slower or even drift away entirely. Think of it like the invisible scaffolding holding up the universe's structure. But if it's everywhere, why can't we detect it directly? The answer lies in its ghostly nature. Dark matter doesn't interact with ordinary matter the way particles like protons or electrons do. It passes right through everything, even you, without a trace. Scientists have built incredibly sensitive detectors deep underground, shielded from cosmic interference, hoping to catch a fleeting interaction. So far, no luck. Some theories suggest dark matter could be made of weakly interacting massive particles, or WIMP, while others propose it might be something entirely different, like actions or even primordial black holes. The mystery is so profound that it's reshaped our understanding of physics itself. One thing's for sure: dark matter is the universe's silent partner, shaping everything we see while remaining utterly hidden. And until we crack its code, this invisible force will keep challenging our quest to understand the cosmos. But don't worry, this is just the beginning. The universe has plenty more secrets waiting to be unraveled. Now, let's tackle one of the most puzzling questions in the cosmos: why, in a universe so vast and ancient, haven't we found any signs of intelligent life beyond Earth? This is the heart of the Fermi Paradox, named after physicist Enrico Fermi, who famously asked, "Where is everybody?" Consider this. Our galaxy alone contains hundreds of billions of stars, many with planets in the habitable zone. With numbers like that, the odds of life emerging elsewhere seem almost guaranteed. Yet, despite decades of searching, our telescopes and radio dishes have picked up nothing but silence. No signals, no alien megastructures, not even a single microbial fossil from another world. So what's going on? One chilling possibility is the Great Filter, a hypothetical barrier that prevents life from advancing to interstellar communication or colonization. The scary part, we don't know if the filter is behind us or ahead of us. If it's behind us, say, the leap from simple cells to complex life is incredibly rare, then we might be among the universe's few success stories. But if it's ahead, like self-destruction through nuclear war or runaway AI, then humanity's future could be grim. Other theories suggest aliens might be avoiding us deliberately, or that advanced civilizations eventually transcend physical forms, leaving no trace we can detect. Some even propose we're living in a cosmic zoo, intentionally isolated by higher beings. The truth is, every answer to the Fermi Paradox is speculative, and that's what makes it so fascinating. It forces us to confront how little we truly understand about life's place in the universe. But one thing's certain, the silence out there isn't just a scientific mystery. It's a mirror reflecting back our own hopes, fears, and the enduring question, are we alone? And with that, we're ready to dive into another cosmic enigma, one where particles defy the laws of physics as we know them. Now let's shift gears to something that even Einstein found unsettling: quantum entanglement, a phenomenon so strange he called it spooky action at a distance. Imagine two particles, like electrons or photons, becoming linked in such a way that whatever happens to one instantly affects the other, no matter how far apart they are. We're talking about distances that could span across galaxies, with the change happening faster than the speed of light. Here's the wild part: this isn't just theory. Experiments have confirmed it time and again. Scientists can create entangled particles in a lab, measure one, and like magic, the other's properties snap into a corresponding state, defying everything classical physics taught us about cause and effect. Einstein hated this idea because it seemed to break the universe's speed limit, the speed of light. But quantum mechanics doesn't play by those rules. So how does it work? Think of it like a pair of cosmic dice. If you roll one and it lands on 6, the other instantly becomes 6 too, even if it's on the other side of the universe. No signal passes between them, no hidden wires, just an inexplicable connection that seems baked into the fabric of reality. Some researchers believe this hints at a deeper layer of the universe we don't yet understand, where space and time might not be as fundamental as we think. The implications are mind-bending. Could we use entanglement for instant communication across interstellar distances? Not exactly. While the correlation is instantaneous, we can't control what state the particles will take, so we can't send messages faster than light. But it's already revolutionizing fields like quantum computing and cryptography, where entangled particles could create unhackable networks. What's truly humbling is that entanglement forces us to rethink reality itself. Particles aren't just tiny billiard balls bouncing around. They're part of a vast, interconnected web where the very idea of separate might be an illusion. And with that, we're ready to unravel another cosmic mystery, one that had astronomers scratching their heads back in 1977. Now, let's dive into one of the most tantalizing mysteries in the search for extraterrestrial intelligence, the WOW signal. Back in August 1977, a radio telescope at Ohio State University picked up something extraordinary. For 72 seconds, a burst of radio waves blared from the constellation Sagittarius, so strong and unusual that astronomer Jerry Amon circled it on the printout and wrote, "Wow." Next to it in red ink, that single word gave the signal its name, and it's been haunting scientists ever since. What made this signal so special? First, it matched the exact frequency that hydrogen, the most common element in the universe, emits naturally. Scientists had theorized that an advanced civilization might use this frequency to communicate, since it's like a cosmic lighthouse. Second, the signal was narrowband, meaning it was focused on one specific wavelength, unlike natural cosmic noise, which tends to be messy and spread out. It looked engineered, not random, but here's the frustrating part. Despite decades of searching, the WOW signal has never been heard again. No follow-up, no repeats, just that one brief blip. Some argue it could have been a passing comet reflecting sunlight, but the timing and frequency don't quite add up. Others suggest it might have been a human-made satellite, but no known technology at the time fits the profile. The most tantalizing possibility, a one-time transmission from an alien civilization, maybe a beacon or even a stray signal we just happened to catch. The WOW signal remains a cosmic tease, a fleeting hint that we might not be alone, but without enough evidence to say for sure. It's a reminder that the universe is full of surprises, and sometimes the most profound mysteries come in the quietest moments. And speaking of quiet, our next secret takes us to the eerie silence of black holes, where information itself seems to vanish without a trace. Now, let's turn our attention to one of the most mind-bending puzzles in modern physics, the black hole information paradox. At first glance, black holes seem simple. They're regions of space where gravity is so intense that nothing, not even light, can escape. But when you dig deeper, they throw a wrench into one of the most fundamental laws of the universe, the principle that information can never be destroyed. According to quantum mechanics, every particle in the universe carries information about its state, its position, momentum, and other properties. Even if matter is scrambled or transformed, that information should still exist in some form. But black holes appear to break this rule. When something falls into a black hole, it's crushed into an infinitely dense point called a singularity. According to Einstein's theory of general relativity, that information is lost forever, gone from the universe. This troubled physicists for decades, including Stephen Hawking, who famously argued that black holes could slowly evaporate over time, releasing energy in the form of what we now call Hawking radiation. But here's the problem. Hawking radiation seems random, carrying no trace of the information that fell into the black hole. If that's true, it means the universe has a way to erase information permanently, something quantum mechanics says should be impossible. Hawking later proposed a potential solution. Maybe the information isn't truly lost. Instead, it could be encoded in the radiation or even on the black hole's event horizon, the point of no return. Other theories suggest black holes might not form singularities at all, or that information escapes through hidden dimensions, but to this day no one knows for sure. The black hole information paradox forces us to confront the limits of our understanding. It's a battle between two pillars of physics, quantum mechanics and general relativity, and solving it might require a whole new theory of everything. And as we grapple with this cosmic mystery, our next secret takes us to another enigma, the universe's missing baryons, where half the normal matter in existence seems to have vanished without a trace. Now let's unravel another cosmic mystery that's been baffling scientists. Where in the universe did half the normal matter go? You'd think something as fundamental as the building blocks of stars, planets, and even us would be easy to track. But here's the twist. When astronomers tally up all the ordinary matter, the stuff made of protons, neutrons, and electrons, known as baryons, they find only about half of what the Big Bang's calculations predict should exist. So where is it hiding? One leading theory points to vast, diffuse filaments of hot gas stretching between galaxies, forming what's called the cosmic web. These threads are so faint and spread out that they're nearly invisible to traditional telescopes. but recent breakthroughs like detecting faint X-ray glows from this gas suggest this could be the missing matter's hiding spot. Another possibility, the matter might be lurking in hard-to-observe regions like the outskirts of galaxy clusters or even in rogue planets drifting between stars. Some could be tied up in faint, low-mass stars or black holes too dim to spot. The challenge is that this missing matter doesn't emit much light, making it like trying to find smoke in a pitch-black room. What's at stake here isn't just a cosmic accounting error. If we can't find this matter, it could mean our understanding of how the universe formed is incomplete, or that there's something fundamentally off about how matter behaves on the largest scales. Solving this puzzle could reshape cosmology itself, and just when you think the universe couldn't get any stranger, our next secret takes us to an eerie alignment in the cosmos that's left scientists scratching their heads, the so-called axis of evil. Now, let's turn our attention to something even more unsettling, a cosmic oddity so peculiar that scientists half-jokingly named it the axis of evil. This isn't some sci-fi villain's lair, but a bizarre pattern in the cosmic microwave background, the afterglow of the Big Bang itself. When researchers mapped this ancient light, they expected it to be evenly distributed, a random scatter of hot and cold spots, proof of the universe's chaotic infancy. Instead, they found something that defies logic, a strange alignment of these temperature fluctuations, almost as if the universe has a preferred direction. Some call it a cosmic axis, others a statistical fluke, but either way, it shouldn't exist according to our standard model of cosmology. The implications are huge. If the universe isn't as uniform as we thought, it could mean our understanding of its birth is missing a critical piece. Maybe the Big Bang wasn't perfectly symmetrical, or perhaps there's an unseen force tugging at the fabric of space-time from beyond our observable universe. Some even speculate it hints at a pre-Big Bang structure, a fingerprint of something older than time itself. What makes this discovery so controversial is that it challenges a cornerstone of modern physics, the cosmological principle, which states that the universe should look roughly the same in all directions. Yet here we are, staring at a cosmic curveball that refuses to play by the rules. And just when you think the cosmos couldn't get any stranger, our next secret takes us to one of the emptiest places in existence, a void so vast it defies explanation. But before we dive into the mysteries of the Boötes Void, let's take a moment to appreciate just how vast and unpredictable our universe truly is. Imagine a region of space so empty, so eerily devoid of galaxies, that it defies everything we know about cosmic structure. This is the Boötes Void, a staggering spherical expanse spanning over 300 million light-years, a cosmic desert where galaxies are almost non-existent. To put that into perspective, if our Milky Way were placed at the center of this void, we wouldn't have discovered other galaxies until the 1960s, because the nearest ones would be tens of millions of light-years away. That's how sparse this region is. While most of the universe is woven together by the cosmic web, an intricate network of galaxies and dark matter, the Boötes Void stands out as a glaring exception. So how did this enormous nothingness come to be? One theory suggests it's the result of smaller voids merging over billions of years, like bubbles combining into one giant cavity. Another, more radical idea proposes that it might be evidence of an ancient collision with another universe, a scar left behind from a multiverse event we can't yet comprehend. And then there's the unsettling possibility that the void isn't entirely empty at all, but filled with some form of invisible matter that doesn't interact with light, making it undetectable to our telescopes. What makes the Boötes Void even more perplexing is that it shouldn't exist in such a size based on our current models of the universe's large-scale structure. It's too big, too empty, and too isolated. Some astronomers argue it's just a statistical anomaly, a rare but natural fluctuation in the cosmic web. Others think it's a clue that our understanding of the universe's evolution is missing a crucial piece. And just when you think the cosmos has shown us all its oddities, our next secret pulls us into an even deeper enigma, one that involves mysterious bursts of energy from the farthest reaches of space. Now, let's shift our gaze to one of the most fleeting yet powerful mysteries in the cosmos: fast radio bursts, or FRB. These are sudden, incredibly intense blasts of radio waves that last just milliseconds but pack more energy than the sun emits in days. What's wild is that they come from galaxies billions of light years away, and we still don't know what's causing them. The first FRB was discovered in 2007, completely by accident, buried in old radio telescope data. Since then, we've detected hundreds more, but only a handful repeat, adding another layer to the puzzle. Some burst once and vanish forever, while others fire off signals at irregular intervals, like a cosmic Morse code with no clear sender. So what could possibly generate such extreme, short-lived energy? Theories range from the dramatic, like colliding neutron stars or black holes, to the downright speculative, including alien megastructures. One leading idea points to magnetars, highly magnetic neutron stars that occasionally unleash violent flares. In 2020, astronomers even linked an FRB to a magnetar in our own galaxy, giving us a potential clue. But here's the catch: most FRBs come from much farther away, and their signals are often distorted by intergalactic plasma, making it hard to trace their exact origins. What's even stranger is that some FRBs seem to follow patterns, with bursts repeating every few months or even days. This has led some scientists to wonder if they're natural cosmic beacons, or if there's some underlying physics we're just not grasping yet. And then there's the sheer power. How can something so brief outshine entire galaxies in radio waves? As we peel back the layers of this enigma, one thing's clear: fast radio bursts are forcing us to rethink what's possible in the universe. And just when we start to piece together a theory, the cosmos throws another curveball our way. Up next, we'll explore an anomaly closer to home, one that defied gravity itself. Now, let's turn our attention to a mystery much closer to home, one that had scientists scratching their heads for decades. The Pioneer anomaly refers to the strange, unexplained slowdown of the Pioneer 10 and 11 spacecraft as they journeyed through the outer solar system. Launched in the early 1970s, these probes were expected to follow the predictable laws of gravity as they drifted farther from the sun. But something was off. They were slowing down just a tiny bit more than calculations predicted, as if an invisible hand was gently tugging them backward. At first, scientists suspected simple explanations, maybe a fuel leak, or thermal radiation from the spacecraft's power systems was nudging them off course. But after years of analysis, none of these could fully account for the discrepancy. The anomaly was small, just a fraction of a nanometer per second squared, but over the vast distances of space, even tiny deviations add up. This wasn't just a glitch, it was a genuine puzzle that challenged our understanding of physics. Some theorists wondered if the anomaly hinted at flaws in Einstein's theory of general relativity, suggesting that gravity might behave differently at the edges of the solar system. Others proposed exotic ideas, like the existence of unseen dark matter tugging on the probes, or even undiscovered dimensions subtly altering the laws of motion. But as more missions, like the New Horizons probe, flew through the same region without showing the same slowdown, the mystery deepened. Then, in 2012, a team of researchers cracked the case, sort of. They realized that heat radiating unevenly from the spacecraft's power systems could create just enough recoil to explain the anomaly. It wasn't new physics, just an overlooked quirk of engineering. But here's the twist: while this explanation fits Pioneer 10 and 11, it doesn't account for every similar anomaly observed in other missions. So, was it really solved, or is there still something we're missing? The Pioneer anomaly reminds us that even in the familiar reaches of our solar system, the universe has a way of keeping us on our toes, and just when we think we've figured it all out, space throws us another curveball. Next up, we'll dive into an interstellar visitor that defied all expectations. Stay tuned. Now, let's shift our gaze beyond our solar system to an object that arrived from the depths of interstellar space, Oumuamua. This strange, elongated visitor was first spotted in October 2017, racing past the Sun at blistering speeds. What made it so extraordinary wasn't just its origin, it was the way it moved. Unlike typical comets or asteroids, Oumuamua didn't follow the predictable path dictated by gravity alone. Instead, it accelerated slightly as it sped away, as if pushed by an unseen force. Scientists scrambled to explain this odd behavior. At first, some thought it might be a comet with outgassing, a release of gas, giving it a gentle push. But telescopes detected no telltale coma or tail, the usual signs of a comet's activity. Others suggested it could be a rare type of hydrogen iceberg sublimating in sunlight, but that theory had its own holes. The more researchers studied Oumuamua, the stranger it seemed. Its shape was another puzzle, likely 10 times longer than it was wide, tumbling end over end like a cosmic cigar. Then came the most provocative idea: could Oumuamua be artificial? A few scientists, like Harvard's Avi Loeb, floated the possibility that it might be a piece of alien technology, perhaps a light sail propelled by starlight or even a derelict probe. The idea sparked fierce debate. Critics argued that extraordinary claims require extraordinary evidence, and Oumuamua's quirks could still have natural explanations, like exotic ices or unusual dust properties. But the truth is, we may never know for sure. By the time we spotted it, Oumuamua was already speeding out of reach, leaving us with more questions than answers. What makes this interstellar visitor so fascinating isn't just its mystery, it's the reminder that our universe is full of surprises, some of which might challenge our very understanding of what's possible. Whether natural or not, Oumuamua has opened a new chapter in astronomy, one where we're now actively searching for more of these cosmic nomads, and who knows? The next one might bring even bigger revelations. Up next, we'll explore another cosmic oddity, a mysterious motion of galaxy clusters that hints at forces beyond our observable universe. Stay curious. Now, let's venture even deeper into the cosmic unknown, where the universe itself seems to be hiding something colossal. Astronomers have noticed something unsettling about the way entire galaxy clusters are moving. They're not just drifting randomly, they're being pulled, as if by an invisible hand, toward a single point in space. This bizarre phenomenon is called the dark flow, and it defies everything we know about how the universe should behave. Here's what makes it so strange. According to the Big Bang theory, the universe should expand evenly in all directions, with galaxies scattering like fragments from an explosion. But when scientists mapped the motion of hundreds of galaxy clusters, they found many of them streaming in the same direction at incredible speeds, some as fast as 2 million miles per hour. Even more puzzling, the source of this pull lies beyond the edge of the observable universe, in a region we can't see or study. So what could be tugging on these galaxies? One leading theory suggests the dark flow might be the gravitational influence of something unimaginably massive, perhaps a supercluster of matter so enormous it warps space-time itself. Others speculate it could be evidence of another universe brushing against ours, a mind-bending idea from multiverse theories. Skeptics argue it might just be a measurement error, but repeated studies keep confirming the anomaly. The dark flow forces us to confront a humbling truth: we might only be seeing a fraction of reality. Whatever's out there beyond our cosmic horizon, it's rewriting the rules. And that's the thrill of astronomy. Every mystery solved reveals a deeper one waiting. Next up, we'll tackle another cosmic headache: why the universe's expansion rate keeps sparking debates among scientists. Stay with us. Now, let's turn our attention to another cosmic puzzle that's leaving scientists scratching their heads: the Hubble tension. This isn't about a telescope feeling stressed. It's a glaring mismatch in how fast the universe is expanding, and it's throwing a wrench into our understanding of cosmology. Here's the problem. Scientists have two main ways to measure the universe's expansion rate, known as the Hubble constant. The first method looks at nearby galaxies and supernova, using their brightness and distance to calculate how quickly they're moving away from us. The second method studies the cosmic microwave background, the faint afterglow of the Big Bang, to infer the expansion rate from the early universe. Both approaches are rock solid in theory, but here's the kicker. They keep giving us different answers. The discrepancy might sound small, but in cosmology, even a tiny gap can signal a massive problem. The nearby measurements suggest a faster expansion rate, while the early universe data points to a slower one. This inconsistency has persisted for years, surviving countless checks and rechecks. So what's going on? Some theorists argue we might be missing a piece of physics, perhaps an unknown form of dark energy that's tweaking the expansion. Others wonder if there's something flawed in our measurements, though no one's found the error yet. The Hubble tension isn't just academic, it's a potential crisis for cosmology. If the discrepancy is real, it could mean our standard model of the universe is incomplete, forcing us to rethink dark energy, gravity, or even the Big Bang itself. Every time we think we've got the cosmos figured out, it throws us a curveball, and that's what makes this so exciting. Science thrives on mysteries. Up next, we'll explore another edge of our solar system where the rules seem to break down. Don't go anywhere, but just when we think we've got a handle on the universe's quirks, another mystery pops up, this time right in our own cosmic backyard. Let's zoom in on the Kuiper belt, that icy ring of debris beyond Neptune where something strange is happening. At a certain distance from the Sun, the number of objects out there drops off dramatically, like a cliff edge in space. Scientists call this the Kuiper cliff, and it's got them wondering, what's causing this sudden vanishing act? The Kuiper belt is packed with frozen leftovers from the solar system's formation. Think of it as a cosmic junkyard filled with dwarf planets, comets, and icy rocks. But around 50 astronomical units from the Sun, that's 50 times the Earth-Sun distance, the belt's population plummets. It's not a gradual fade, it's an abrupt cutoff, as if someone drew a line and said, no more objects beyond this point. So what's behind this eerie emptiness? One leading theory points to Planet 9, that hypothetical giant lurking in the outer solar system. If it exists, its gravity could have swept the area clean, hurling objects inward or flinging them into deep space. Another idea suggests the cliff marks the edge of the primordial solar system, where the disk of material that formed our planet simply ran out. Or maybe the objects are there but too faint for our telescopes to spot, hidden in the darkness, waiting to be discovered. The Kuiper cliff isn't just a curiosity, it's a clue to the solar system's turbulent past, whether it's evidence of a hidden planet, a fossilized boundary, or something even weirder. This cosmic drop-off reminds us that even our neighborhood still holds secrets. And speaking of hidden giants, our next stop takes us deeper into the hunt for one of the solar system's most elusive suspects. Stay tuned. Now, let's turn our attention to one of the most tantalizing hunts in modern astronomy, the search for Planet 9. This isn't just about adding another world to our solar system's lineup. It's about solving a gravitational puzzle that's been teasing scientists for years. The story begins with the odd behavior of objects in the Kuiper belt. Some of these icy bodies follow such strange, elongated orbits that they seem to be tugged by something massive, something we can't see. Their paths cluster in a way that suggests the influence of a hidden giant, roughly 10 times the mass of Earth, lurking far beyond Pluto. That's where the Planet 9 hypothesis comes in. Researchers have run countless simulations, and the math keeps pointing to the same conclusion. An undiscovered planet could explain these orbital anomalies. Its gravity would act like an invisible hand, shepherding distant objects into their peculiar trajectories. But if it's out there, why haven't we spotted it yet? Well, this hypothetical world could orbit up to 20 times farther from the Sun than Neptune, making it incredibly faint and slow-moving. spotting it would be like finding a single dim light bulb in a vast, dark field. The search is far from easy. Telescopes like Subaru and the Vera C. Rubin Observatory are scanning the skies, piecing together clues. Some astronomers even suggest Planet 9 might not be a planet at all, but a primordial black hole, a leftover from the early universe. Wild, right? Whether it's a rogue planet or something even stranger, the hunt for Planet 9 reminds us that our solar system still has surprises up its sleeve. And as we push the boundaries of discovery, who knows what else might be hiding in the shadows? Up next, we'll explore an even bigger cosmic collision, one that's been billions of years in the making. Now, let's shift our gaze to a cosmic event that will rewrite the night sky, the inevitable collision between our Milky Way and the Andromeda galaxy. This isn't some distant sci-fi scenario. It's a future written in the stars, set to unfold in about 4 billion years. Picture this: Andromeda, our closest galactic neighbor, is hurtling toward us at roughly 250,000 miles per hour. But don't panic, galactic collisions are more like a slow-motion dance than a destructive crash. When these two giants meet, their immense gravitational pull will warp their shapes, stretching stars and gas into dazzling tidal tails. Here's the surprising part: individual stars are so far apart that actual collisions are rare. Instead, the galaxies will merge over billions of years, eventually forming a single, elliptical galaxy some astronomers call Milkdromeda, our solar system. It'll likely be flung into a new orbit, but the chances of it being disrupted are slim. What does this mean for life on Earth? By then, the Sun will have already entered its red giant phase, making our planet uninhabitable long before the merger completes. But the spectacle itself, a sky filled with two glowing galactic cores, would be breathtaking for any future observers. This cosmic tango reminds us that the universe is anything but static. Even galaxies, those seemingly eternal islands of stars, are constantly evolving. Up next, we'll turn to a star that's baffling astronomers with its unpredictable flickers, Tabby star. Now, let's turn our attention to one of the most puzzling stars in the cosmos, Tabby star, officially known as KSE 8462852. This strange celestial object has left astronomers scratching their heads with its bizarre, unpredictable dimming patterns. Unlike most stars, which dim in regular, measurable cycles, Tabby's star flickers erratically, sometimes dropping in brightness by as much as 22% before bouncing back. So, what's causing these dramatic dips? The theories are as wild as they are fascinating. One leading idea suggests swarms of comets or vast clouds of cosmic dust could be passing in front of the star, blocking its light. But here's where it gets even more intriguing. Some scientists have floated the possibility of alien megastructures, like a Dyson sphere, a hypothetical energy-harvesting construct built by an advanced civilization. While that might sound like science fiction, the truth is, we still don't have a definitive answer. What makes Tabby's star even more mysterious is that its long-term dimming trend doesn't fit any known natural explanation. Over the past century, it's gradually grown fainter, adding another layer to the enigma. Could it be an entirely new astrophysical phenomenon we've yet to discover? For now, Tabby's star remains one of the universe's great unsolved riddles, a reminder that even the most familiar objects in the sky can hide astonishing secrets. Next up, we'll unravel the cosmic web, the hidden scaffolding that shapes the universe itself. Now, let's pull back the curtain on one of the universe's grandest blueprints, the cosmic web. Picture the universe not as a random scattering of galaxies, but as an intricate, interconnected network, like neurons in a colossal brain or veins in a leaf. This vast filamentary structure is made up of galaxies, gas, and dark matter, stretching across billions of light years in delicate threads, dense knots, and enormous voids. At the heart of this cosmic architecture is dark matter, the invisible scaffolding that shapes everything. Though we can't see it directly, its gravitational pull draws ordinary matter into these sprawling filaments, where galaxies form like beads on a string. The densest intersections of these threads become galaxy clusters, some of the most massive structures in the universe, while the empty spaces between them stretch into voids so large they could swallow thousands of Milky Ways. What's truly mind-bending is how this web mirrors the universe's earliest moments. Tiny fluctuations in the primordial soup of the Big Bang, amplified by gravity over billions of years, grew into the web we see today. It's a fossil record of cosmic evolution, written in the language of gravity and dark matter. Scientists mapped this hidden structure using advanced telescopes and simulations, revealing a universe far more organized and mysterious than we once imagined. And just like Tabby's star, the cosmic web reminds us that the universe's greatest secrets often lie in the spaces between what we can see. Up next, we'll venture into one of those eerie voids, the Eridanus supervoid, where the cosmos seems to vanish altogether. Now, let's step into one of the universe's most unsettling empty spaces, the Eridanus supervoid. Imagine a region so vast and empty that it defies our expectations of how the cosmos should look. Stretching over an astonishing 1 billion light-years, this enormous void is one of the largest structures ever discovered, a cosmic desert where galaxies are almost entirely absent. What makes this supervoid even more intriguing is its possible connection to the cosmic microwave background's mysterious cold spot, an unusually chilly patch in the afterglow of the Big Bang. Scientists have long puzzled over why this cold spot exists, and one leading theory suggests the Eridanus supervoid might be the culprit. Here's how it works. As light from the early universe travels through such a massive void, it loses energy, stretching into longer, cooler wavelengths, like a marathon runner slowing down after crossing a vast, empty plain. But not everyone is convinced. Some argue the supervoid isn't large enough to explain the cold spot's extreme temperature drop, leaving room for wilder possibilities like a collision with another universe or flaws in our understanding of cosmology itself. Whether it's a cosmic coincidence or a clue to deeper mysteries, the Eridanus supervoid challenges our assumptions about the universe's structure. Up next, we'll explore another mind-bending phenomenon, the unruh effect, where acceleration through empty space might conjure particles out of nothingness. Now let's shift gears to something even more mind-bending, the unruh effect. Picture this: you're floating in the emptiness of space, surrounded by what seems like pure nothingness. But if you suddenly accelerate, something strange happens. The vacuum around you, which should be completely empty, starts to glow with particles. That's the unruh effect in action, a bizarre prediction of quantum physics where acceleration makes particles appear out of thin air. Here's how it works. According to quantum field theory, a vacuum isn't truly empty. It's a seething soup of virtual particles popping in and out of existence. Normally, these particles cancel each other out so quickly we can't detect them. But if you accelerate fast enough, your motion disturbs this delicate balance. From your perspective, the vacuum heats up, and those fleeting virtual particles become real, like a cosmic mirage turning solid. The catch: the acceleration needed to see this effect is extreme, far beyond anything humans or even our fastest spacecraft could achieve. We're talking about accelerations close to the speed of light. That's why the unruh effect remains purely theoretical for now. But if we could observe it, it would reveal a profound truth. Reality itself depends on how you're moving. What looks like empty space to one observer could be a shower of particles to another. This effect also ties into one of the biggest mysteries in physics, the connection between acceleration and gravity. Einstein's equivalence principle tells us that standing in a gravitational field feels the same as accelerating through space. So if acceleration creates particles, does gravity do the same? Some scientists think so, suggesting black holes might emit radiation in a similar way, a hint that the unruh effect could help us unravel deeper cosmic puzzles. Up next, we'll tackle another enigma, the Black Knight satellite, an alleged alien artifact orbiting Earth. Is it a relic from another civilization or just space debris? Let's find out. Now, let's turn our attention to a mystery that blurs the line between science and science fiction, the Black Knight satellite. For decades, rumors have swirled about an ancient alien object silently orbiting Earth, watching us from the shadows of space. But what's really up there? The story begins in the late 1950s, when newspapers reported strange radio signals supposedly coming from an unknown satellite. At the time, no human-made object should have been in orbit, sparking wild theories about extraterrestrial technology. Then, in 1998, astronauts on the space shuttle Endeavour captured images of a dark, irregularly shaped object during a mission. Conspiracy theorists latched onto these photos, claiming it was the Black Knight, a relic from an advanced civilization, possibly thousands of years old. But here's where fact steps in. The signals from the 50s, they were likely natural radio noise misinterpreted as artificial, and that mysterious object photographed by the Endeavour crew. It was almost certainly a thermal blanket lost during a spacewalk, tumbling harmlessly in orbit. Even the name Black Knight seems to be a mix-up, borrowed from a British satellite project that never left the drawing board. So why does the myth persist? Part of it is the allure of the unknown, the idea that we're not alone, and that evidence might be hiding in plain sight. But it's also a reminder of how easily space debris and optical illusions can fuel speculation. The truth is, Earth's orbit is crowded with defunct satellites, rocket parts, and other human-made clutter. While none of it is alien, the real mystery is how we'll clean it all up before it becomes a hazard. Still, the Black Knight legend endures, a testament to our fascination with the cosmos and the stories we tell about it. Next up, we'll shift from myth to marvel with a planet that might just be the universe's most extravagant jewel, the Diamond Planet. Now, let's step into the dazzling realm of cosmic luxury with a planet that might just be the universe's ultimate treasure, 55 Cancri, better known as the Diamond Planet. Imagine a world where the ground beneath your feet isn't rock or sand, but glittering diamond. Sounds like something out of a sci-fi fantasy, right? But this planet is very real, and its story is even more fascinating than fiction. Located about 40 light-years away in the constellation Cancer, 55 Cancri orbits so close to its star that a single year there lasts just 18 hours. The intense heat and pressure on this super-Earth, a planet with a mass several times greater than our own, have likely transformed its carbon-rich interior into something extraordinary. Scientists believe that under these extreme conditions, carbon crystallizes into diamond, meaning this planet could be 1/3 pure diamond. To put that into perspective, if you could somehow mine it, which, let's be clear, is impossible with our current technology, its value would dwarf Earth's entire economy. But how does a diamond planet even form? It starts with a star system rich in carbon, the same element that makes up diamonds here on Earth. When planets form in such a system, they inherit that carbon abundance. For 55 Cancri, its close orbit to its star means temperatures soar to thousands of degrees, melting carbon into a sea of liquid diamond beneath a surface that might be covered in graphite, another form of carbon. Over time, the crushing pressures solidify that molten diamond into a vast planetary-scale gemstone. Of course, this isn't a serene, sparkling paradise. The planet's surface is likely a scorching, hostile wasteland, with temperatures hot enough to melt metal and an atmosphere that might consist of vaporized rock. Yet, the idea of a diamond planet challenges our imagination and reminds us just how diverse and bizarre the universe can be. Next, we'll venture into a cosmic conspiracy that rewrites history itself, the phantom time hypothesis, where centuries might not have happened at all. Now, let's take a sharp turn from cosmic wonders to a mind-bending historical mystery, the phantom time hypothesis. What if I told you that 300 years of history might never have actually happened? That's the startling claim at the heart of this controversial theory, which suggests a chunk of our past was fabricated or misrecorded. The idea was first proposed by German historian Heribert Illig in the 1990s. He argued that the years between 614 and 911 were invented, either by mistake or as part of a deliberate conspiracy. His theory hinges on inconsistencies in historical records, architectural styles, and even astronomical events from that period. For example, Illig pointed out that the Gregorian calendar reform in 1582 supposedly corrected a 10-day drift caused by an inaccurate Julian calendar. But according to his calculations, the drift should have been closer to 13 days if those phantom centuries were real. Supporters of the hypothesis also highlight gaps in archaeological evidence and the sudden reappearance of certain technologies that seem out of place in the timeline. Skeptics, however, dismiss these claims, pointing to extensive documentation from other cultures, like the Byzantine and Islamic worlds, which show continuous historical records during the same period. Astronomical observations such as recorded eclipses also align with the traditional timeline, casting serious doubt on the theory. So why does this idea persist? It taps into our fascination with hidden truths and the possibility that history isn't as solid as we think. Whether you find it intriguing or far-fetched, the phantom time hypothesis forces us to question how we reconstruct the past and how much we truly know. Next, we'll shift our gaze back to the cosmos to uncover strange patterns in the universe's oldest light, the cosmic microwave background's anomalies. Leaving behind the tangled threads of history, let's return to the cosmos and examine something far older, the cosmic microwave background, or CMB. This faint glow is the universe's oldest light, a relic from when the cosmos was just 380,000 years old. But here's the twist: this ancient snapshot isn't as uniform as scientists expected. Strange anomalies in its patterns have sparked debates that could shake the foundations of the Big Bang theory. One of the most puzzling quirks is the so-called axis of evil, a bizarre alignment of temperature fluctuations in the CMB that seems to defy randomness. Instead of being scattered evenly, these hot and cold spots appear to line up in a way that suggests a preferred direction in space, something the Big Bang's principle of isotropy says shouldn't happen. If the early universe was truly uniform, why does this axis exist? Some researchers argue it's just a statistical fluke, while others wonder if it hints at a deeper, unknown structure to reality. Then there's the mysterious cold spot, a sprawling region in the CMB that's significantly cooler than its surroundings. One explanation proposes it's a cosmic supervoid, a vast emptiness where matter is unusually sparse. But even that doesn't fully account for its temperature. Could it be evidence of a collision with another universe or something even stranger? These anomalies don't just challenge the Big Bang, they force us to ask whether we're missing a fundamental piece of the puzzle. Maybe the universe isn't as random as we thought, or maybe our theories need reworking. Either way, the CMB's secrets remind us that even the most well-tested ideas can hide surprises. Up next, we'll zoom in on another cosmic oddity, the Red Rectangle Nebula, where geometry takes on an almost unnatural perfection. Shifting our gaze from the cosmic microwave background's mysteries, let's marvel at a celestial structure so precise it almost feels designed, the Red Rectangle Nebula. Nestled about 2,300 light-years away in the constellation Monoceros, this nebula defies the chaotic beauty of most cosmic formations with its near-perfect X-shape. At its heart lies a dying star, HD 44179, whose expelled layers of gas and dust have sculpted this geometric wonder. But how does nature produce such symmetry? One leading theory suggests the star's intense bipolar jets, twin streams of matter shooting in opposite directions, collide with a dense disk of dust encircling it. The result, a stunning hourglass-like structure that, from our vantage point, appears as an X. Yet even this explanation leaves gaps. Why is the red rectangle so strikingly symmetrical when most bipolar nebulae are messy and irregular? Some scientists speculate that a companion star, hidden within the nebula's glow, might be shaping the outflow with its gravitational pull. Then there's the nebula's eerie red hue, caused by a rare form of carbon molecules called polycyclic aromatic hydrocarbons. These molecules fluoresce under the dying star's ultraviolet light, painting the nebula in crimson. But here's the kicker: the red rectangle isn't just red. Infrared observations reveal intricate ladder-like rungs within its arms, a feature unseen in any other nebula. Are these rungs echoes of periodic outbursts from the central star, or clues to an even deeper puzzle? The red rectangle challenges our assumptions about how stars die and how chaos can birth order. Whether it's the work of hidden stellar partners or undiscovered physics, one thing's clear: this cosmic masterpiece reminds us that the universe has a flair for the unexpected. Next, we'll confront a silence louder than any signal, the unsettling mystery of the Great Silence, and why the cosmos seems so empty of intelligent life. Now let's turn our attention to one of the most haunting questions in astronomy, the Great Silence. With billions of planets in our galaxy alone, many of them Earth-like and potentially habitable, why haven't we detected a single whisper of intelligent alien life? This eerie absence of contact is known as the Fermi Paradox, named after physicist Enrico Fermi, who famously asked, "Where is everybody?" One possible answer lies in the sheer vastness of space. Even if civilizations exist, the distances between stars are so enormous that communication or travel might be nearly impossible. Imagine shouting into a hurricane; your voice would be lost in the noise. Similarly, our radio signals and probes might simply be too faint or too slow to reach anyone listening. Then there's the grim possibility of the Great Filter, a hypothetical barrier that prevents life from advancing to interstellar communication. This could be anything from self-destruction through war or environmental collapse to rare planetary conditions that make complex life vanishingly unlikely. If the filter lies ahead of us, humanity's future might be bleak. If it's behind us, we might truly be alone. Others suggest that advanced civilizations might be hiding, either by choice or necessity. Perhaps they've evolved beyond detectable technology, or they're avoiding contact to protect us or themselves. There's also the eerie idea that we're living in a cosmic zoo, deliberately isolated by unseen observers. But here's the twist: our search has barely begun. We've only scanned a tiny fraction of the sky, and our technology is still primitive compared to what might be out there. The silence might not be a verdict, just a pause before the universe finally answers. Up next, we'll flip the script on black holes and explore the tantalizing possibility of their opposite, white holes, and whether they could really exist. Now, let's shift our gaze from the eerie silence of the cosmos to something even more mind-bending: white holes. If black holes are the universe's ultimate vacuum cleaners, sucking in everything that crosses their path, white holes are their hypothetical opposites. Picture a cosmic fountain, endlessly spewing out matter and energy instead of swallowing it. While black holes trap light, white holes would repel it, making them just as mysterious but in reverse. The idea of white holes comes straight from the math of Einstein's theory of general relativity. The equations that describe black holes also allow for solutions that behave like their mirror images, white holes. But here's the catch: while black holes form naturally when massive stars collapse, white holes would require some exotic mechanism to exist. They'd need to burst into being fully formed, ejecting material without ever having absorbed it. That's a tough sell for physics as we know it. Some scientists speculate that white holes could be the other end of a black hole's tunnel, a wormhole's exit. If you fell into a black hole, perhaps you'd be spat out through a white hole somewhere else in the universe. It's a wild idea, but so far, no white holes have been observed, and their existence remains purely theoretical. Then there's the energy problem. white holes would defy the second law of thermodynamics, which says entropy, or disorder, always increases. A white hole ejecting pristine, organized energy seems to break that rule. Unless, of course, the universe has tricks we haven't discovered yet. Could white holes be real? For now, they're more like cosmic thought experiments, pushing the boundaries of what we think is possible. But in a universe full of surprises, who's to say they aren't lurking out there, waiting to be found? Up next, we'll unravel another lunar mystery: why the moon once had a magnetic field and what caused it to vanish. Now, let's turn our attention to a mystery much closer to home: the moon's lost magnetic field. Today, our moon is a quiet, barren world with no global magnetic shield, but billions of years ago, it was a different story. Scientists believe the moon once had a magnetic field, possibly even stronger than Earth's at the time. So what happened to it? The leading theory points to the moon's molten core. Early in its history, the moon's interior was hot and churning, with liquid metal moving in a dynamo effect similar to how Earth's core generates our magnetic field today. But the moon is much smaller than Earth, so its core cooled down faster. As the heat faded, the dynamo effect weakened, and eventually the magnetic field vanished. Another clue comes from moon rocks. Samples brought back by the Apollo missions contain traces of magnetism, proving the moon once had an active magnetic field. But here's the twist: some of these rocks are younger than the period when the dynamo should have already died out. That suggests something else, like massive asteroid impacts, might have briefly reignited the moon's magnetic field in short bursts. Then there's the question of timing. The moon's magnetic field likely faded around 1 billion years ago, but the exact process remains hazy. Did it shut off suddenly, or was it a slow, sputtering decline? Without more data, it's hard to say. One thing's for sure: the moon's magnetic past adds another layer to its complex history. And if we ever establish a permanent base there, understanding these ancient forces could be key to protecting future explorers from cosmic radiation. Next up, we'll journey to the far reaches of the cosmos to examine the Hercules-Corona Borealis Great Wall, a structure so vast it challenges our understanding of the universe's scale. Now, let's stretch our imaginations even further as we venture into the mind-bending scale of the Hercules-Corona Borealis Great Wall. This colossal structure isn't just big, it's one of the largest known formations in the entire universe, spanning an astonishing 10 billion light-years across. To put that into perspective, that's roughly 1/10 the diameter of the observable universe itself. Discovered in 2013 by mapping gamma-ray bursts, this cosmic behemoth is essentially a vast filament of galaxies, galaxy clusters, and dark matter, woven together in a structure so immense it defies our current understanding of cosmology. According to the cosmological principle, matter should be distributed fairly evenly across the universe on the largest scales. But the Hercules-Corona Borealis Great Wall throws that idea into question. Its sheer size suggests there might be unknown processes at work, shaping the cosmos in ways we don't yet comprehend. So how did something this massive form? One theory points to gravitational anomalies in the early universe, where slight density fluctuations allowed matter to clump together on scales far grander than expected. Another possibility is that we're seeing the imprint of cosmic inflation, the rapid expansion of the universe just after the Big Bang, stretching these structures to unimaginable proportions. But here's the real puzzle. If structures like this exist, they might force us to rethink the limits of cosmic evolution. Some scientists argue that the Great Wall could even hint at deeper mysteries, like the influence of dark energy or undiscovered physics governing the large-scale structure of space. As we continue mapping the cosmos, discoveries like this remind us just how much we still have to learn. Up next, we'll confront another head-scratcher, the vacuum catastrophe, where the energy of empty space doesn't add up the way it should. Now, let's shift our gaze to one of the most baffling mismatches in modern physics, the vacuum catastrophe. imagine the empty space around us isn't really empty at all. According to quantum mechanics, even a perfect vacuum buzzes with energy, thanks to fleeting particles popping in and out of existence. Scientists call this vacuum energy, and here's where things get weird. When theorists calculate how much energy this quantum activity should generate, the numbers are astronomically higher, around 120 orders of magnitude stronger than what we actually observe in the universe. That's like predicting a tsunami and instead finding a single ripple in a teacup. So why does reality disagree so violently with theory? One explanation is that we're missing a crucial piece of the puzzle, perhaps a hidden symmetry or an undiscovered law that cancels out most of this energy. Another idea is that vacuum energy isn't constant but varies across space, averaging out to the tiny value we detect. Some even speculate that multiple universes with different vacuum energies exist, and we just happen to live in one where the number is oddly small. But the stakes are high. Vacuum energy isn't just a curiosity, it's tied to dark energy, the mysterious force accelerating the universe's expansion. If we can't explain this discrepancy, our understanding of cosmic evolution might be fundamentally flawed. It's as if the universe left us a glaring error in its equations, daring us to solve it. Up next, we'll examine another cosmic outlier, a galaxy that defies expectations by lacking dark matter entirely. How can something so fundamental just disappear? Stay tuned. Now, let's turn our attention to a cosmic oddball that's rewriting the rules: NGC 1052 DF2, a galaxy that shouldn't exist. Dark matter is supposed to be the invisible glue holding galaxies together, making up roughly 85% of the universe's matter. But this strange galaxy, it's missing almost all of it. When astronomers first studied NGC 1052 DF2, they expected to find the usual gravitational pull from dark matter. Instead, the stars inside were moving so slowly that the galaxy barely had any extra mass at all. It was like watching a car roll downhill without an engine. Something fundamental was missing. This discovery sent shockwaves through astrophysics because dark matter isn't just a minor ingredient. It's the scaffolding for galaxy formation. Without it, theorists struggle to explain how such a structure could even form in the first place. So what's going on here? One possibility is that NGC 1052 DF2 had its dark matter ripped away by a neighboring galaxy's gravity, leaving behind a ghostly skeleton of stars. Another idea is that it formed differently, perhaps from gas flung out during a violent galactic collision, but neither explanation fully accounts for its bizarre properties. The real puzzle is what this means for our cosmic models. If dark matter isn't always present, does that imply alternative forms of gravity? Or could there be exotic types of dark matter that behave in ways we haven't predicted? Every time we think we've got the universe figured out, it throws us a curveball like this, forcing us to question the very foundations of physics. Coming up next, we'll investigate another Martian mystery, the sporadic bursts of methane that could hint at life beneath the planet's surface. What's causing these fleeting signals? Stick around to find out. Now, let's shift our gaze from the depths of space to our rusty neighbor, Mars, where a tantalizing mystery has scientists scratching their heads: the sporadic bursts of methane in its thin atmosphere. On Earth, methane is often a byproduct of life, from cow digestion to decaying plants. So when rovers and orbiters detected whiffs of this gas on Mars, the immediate question was, could this be a sign of something alive beneath the surface? The intrigue lies in the unpredictability. Unlike Earth, where methane sources are steady, Mars releases it in fleeting, localized puffs. Some measurements show methane levels spiking tenfold in just hours, only to vanish days later. This erratic behavior makes it even harder to pin down the source. Geologists point to possible non-biological explanations, like serpentinization, a chemical reaction between water and certain rocks that produces methane. Or perhaps ancient methane, trapped underground for eons, is seeping out through cracks. But the timing and distribution of these bursts don't always fit neatly with these theories. Then there's the biological angle. On Earth, microbes called methanogens thrive in oxygen-poor environments like deep underground or in animal guts. Could similar organisms be lurking beneath Mars' icy soil, releasing methane as they metabolize? It's a thrilling possibility, but without direct evidence, it remains just that, a possibility. The stakes are high. If the methane is biological, it would be the first concrete hint of life beyond Earth. If it's geological, it still reveals active processes reshaping Mars today. Either way, solving this puzzle could redefine our understanding of the red planet's hidden dynamics. Up next, we'll delve into an even grander cosmic enigma, the hypothetical Dyson sphere, a megastructure that could harness a star's entire energy. What would it take to build one, and could aliens already have done it? Stay tuned. Now, let's stretch our imaginations beyond our solar system to a concept so grand it could redefine how civilizations harness energy, the Dyson sphere. Picture a colossal structure built around an entire star, capturing its light and heat to power an advanced alien society. This isn't science fiction, but a serious idea proposed by physicist Freeman Dyson in the 1960s, suggesting that a highly developed civilization might need such a megastructure to meet its energy demand. The logic is simple. As a civilization grows, so does its hunger for energy. Eventually, the resources of a single planet wouldn't be enough. Building a Dyson sphere, or even a partial swarm of orbiting solar collectors, would allow a species to tap into nearly all the energy their star produces. Imagine the scale. Our sun emits enough energy in 1 second to power human civilization for hundreds of thousands of years. A Dyson sphere would make that energy available on demand. But how would we even detect such a thing? Astronomers have looked for unusual infrared signatures, since a Dyson sphere would absorb starlight and re-emit it as heat. A few stars, like Tabby's star with its bizarre dimming patterns, have sparked speculation, though natural explanations are more likely. The real challenge is distinguishing a megastructure from cosmic phenomena like dust clouds or planetary debris. Then there's the engineering hurdle. Constructing a Dyson sphere would require dismantling planets for raw materials, mastery of robotics or self-replicating machines, and technology far beyond our current grasp. Some argue that if a civilization could build one, they'd likely have moved beyond the need for it, using more exotic energy sources instead. Yet the idea endures because it forces us to think big. If aliens exist, how might they reshape their environment? And if we ever found evidence of a Dyson sphere, it would be the ultimate clue that we're not alone. Up next, we'll confront an even deeper cosmic mystery, the accelerating expansion of the universe and the dark energy puzzle that keeps scientists awake at night. What's pushing the cosmos apart, and why is it speeding up? That's coming right up. Now, let's turn our attention to one of the most baffling discoveries in modern cosmology: dark energy. Imagine the universe not just expanding, but doing so at an ever-increasing speed, as if some invisible force is pushing galaxies apart faster and faster. This isn't just a curiosity, it's a fundamental mystery that challenges our understanding of physics itself. Back in the late 1990s, astronomers studying distant supernova made a shocking realization. These exploding stars were fainter than expected, meaning they were farther away than predicted. The only explanation, the expansion of the universe, wasn't slowing down, as everyone assumed it was accelerating. This revelation turned cosmology upside down and earned the researchers a Nobel Prize. But what's causing this acceleration? Enter dark energy, the placeholder name for whatever this mysterious force might be. Here's the puzzle. According to Einstein's theory of general relativity, empty space isn't truly empty. It can possess energy, dubbed vacuum energy. One possibility is that dark energy is this inherent energy of space itself, growing stronger as the universe expands. But there's a problem. When physicists calculate how much vacuum energy there should be, the number is astronomically off, up to 120 orders of magnitude too large. If their math were correct, the universe would have torn itself apart long ago. Clearly, something's missing. Another idea is that dark energy isn't constant but evolves over time, perhaps tied to an undiscovered field or particle. Some theories even suggest gravity itself behaves differently on cosmic scales, though no evidence has confirmed this yet. The truth is we're still grasping at straws. Dark energy makes up roughly 68% of the universe's total energy content, yet we know almost nothing about it. What's next? Projects like the Euclid Space Telescope and the Vera Rubin Observatory aim to map the universe's expansion with unprecedented precision, hunting for clues in the distribution of galaxies and the bending of light. If we're lucky, they might reveal whether dark energy is static or changing, narrowing down the possibilities. But here's the thrilling part. Solving this puzzle could rewrite the laws of physics, unlocking secrets about the universe's ultimate fate. Will expansion continue forever, leaving galaxies isolated in a cold, dark void? Or could dark energy evolve in a way we can't yet predict? The answers are out there, hidden in the fabric of space-time itself. Up next, we'll dive into another cosmic head-scratcher, the strange behavior of neutrinos, and how these ghostly particles defy the rules we thought we knew. Stay tuned. Now, let's shift our focus to one of the most elusive particles in the universe, neutrinos. These ghostly particles are so tiny and slippery that they can pass through entire planets without a single interaction. But here's where things get weird. Neutrinos have a bizarre habit of shape-shifting as they travel, flipping between three different flavors: electron, muon, and tau neutrinos. This phenomenon, called neutrino oscillation, shouldn't happen according to the standard model of particle physics, the rulebook that's guided our understanding of the subatomic world for decades. So why does this matter? Well, the standard model assumes neutrinos are massless, but oscillations prove they must have at least some tiny amount of mass. That's a huge problem because the model doesn't account for it. It's like discovering a hidden room in a house you thought you knew inside out. Scientists have been scrambling to revise the rules, but so far no one's cracked the code. The mystery deepens when you consider where neutrinos come from. They're produced in nuclear reactions like those in the sun or during supernova explosions, and they flood the universe in unimaginable numbers. Trillions pass through your body every second, completely unnoticed. Yet, despite their abundance, they're incredibly hard to study. Detecting them requires massive, ultra-sensitive experiments buried deep underground, like Japan's Super Kamiok or the ice cube detector in Antarctica. What's even stranger is that neutrinos might hold clues to one of cosmology's biggest puzzles: why the universe is made of matter and not antimatter. According to the laws of physics, both should have been created in equal amounts during the Big Bang, canceling each other out. But somehow, matter won out, and neutrinos could be the key to understanding why. Some theories suggest that neutrinos and their antimatter counterparts behave differently, tipping the cosmic scales in favor of matter. As researchers dig deeper, neutrino anomalies keep piling up. Experiments have spotted discrepancies in how often neutrinos switch flavors, hinting at yet undiscovered physics. Could there be a fourth type of neutrino, a sterile one that interacts only through gravity? Or does this point to something even more revolutionary, like extra dimensions or a whole new framework beyond the standard model? One thing's certain: neutrinos are far from ordinary. They're cosmic shape-shifters, rule breakers, and maybe even universe makers. And as we peel back their secrets, we might just rewrite the story of reality itself. Next up, we'll turn our attention to another enigmatic signal from the cosmos, the unexplained gamma-ray excess at the heart of our galaxy. Stay curious. Now let's journey to the heart of our own galaxy, where a strange glow of gamma rays has left scientists scratching their heads. Deep in the Milky Way's core, telescopes have detected an unexpected excess of these high-energy photons, more than any known cosmic source can explain. It's like finding a spotlight in the middle of a dark forest with no one holding the switch. At first, researchers thought pulsars, spinning neutron stars, might be responsible. These dense stellar corpses emit beams of radiation as they rotate like cosmic lighthouses. But when they tallied up all the known pulsars in the region, the numbers didn't add up. The gamma-ray excess was far too intense, stretching across thousands of light years. Then came a more tantalizing possibility: dark matter. Some theories suggest that when these invisible particles collide, they could annihilate each other, releasing gamma rays as a byproduct. The galactic center, packed with dark matter, would be the perfect place to spot such signals. If true, this could finally give us a way to see dark matter indirectly, a monumental breakthrough. But not everyone's convinced. Alternative explanations range from rogue cosmic rays slamming into gas clouds to ancient stellar explosions we've yet to uncover. Even mundane sources like a population of faint, undiscovered pulsars haven't been ruled out. The debate is far from settled, and every new observation adds twists to the puzzle. What makes this mystery so thrilling is its scale. These gamma rays aren't just a local oddity, they're a window into the fundamental workings of the universe. Whether it's dark matter revealing itself or an entirely new astrophysical phenomenon, the answer could reshape our understanding of the cosmos. Up next, we'll explore another cosmic head-scratcher: galaxies that seem to have aged too fast, defying our timeline of the universe's evolution. The plot thickens. Now, let's rewind the cosmic clock to a time when the universe was just a fraction of its current age, a time when, according to our best theories, galaxies should have been messy, chaotic infants. But here's the twist: astronomers have spotted galaxies that look suspiciously grown up, as if they skipped childhood entirely. These cosmic overachievers found in the early universe are packed with mature stars, well-defined shapes, and even supermassive black holes, features that, by all accounts, shouldn't exist so soon after the Big Bang. Imagine stumbling upon a toddler who's already graduated college. That's the level of bafflement these galaxies bring. The current timeline of cosmic evolution suggests it should take billions of years for galaxies to settle into orderly spirals or ellipticals, yet these ancient systems appear fully formed when the universe was barely a billion years old. Some even show signs of having stopped forming stars altogether, a process typically associated with much older galaxies. So, what's going on? One possibility is that our understanding of galaxy formation is missing a crucial piece. Maybe the early universe had denser pockets of dark matter, allowing galaxies to assemble faster than we thought. Or perhaps there were exotic physical processes at play, like supercharged star formation or rapid black hole growth, that accelerated their development. Then there's the wild card: what if the universe itself is older than we think? While the evidence for the Big Bang is overwhelming, these mature galaxies have sparked fringe debates about whether our cosmic age estimates need tweaking. Most scientists, though, believe the answer lies in refining our models rather than rewriting cosmic history. Every new telescope, like the James Webb Space Telescope, peels back another layer of this mystery, revealing even more of these impossibly mature galaxies. With each discovery, the pressure mounts to explain how they defied the odds and what it means for our story of the universe's youth. Next up, we'll venture to Venus, where a swirling, double vortex at its south pole has left scientists equally puzzled. The universe, it seems, loves keeping us on our toes. Now, shifting our gaze from the ancient mysteries of early galaxies, let's zoom in on our own solar system, where Venus, Earth's so-called twin, holds a bizarre atmospheric secret. At its south pole, a massive, double-layered vortex swirls endlessly, defying expectations and leaving scientists scratching their heads. This isn't just any storm. Unlike Earth's hurricanes, which form and fade, the Venusian vortex is a permanent fixture, a towering whirlwind of sulfuric acid clouds spinning at dizzying speeds. What makes it even stranger is its shape: two distinct layers of rotating atmosphere, stacked like a cosmic double-decker, each moving independently of the other. So why does Venus have this eerie, persistent whirlwind? The planet's thick, toxic atmosphere rotates much faster than its surface, a phenomenon called superrotation. As winds whip around Venus at hundreds of kilometers per hour, they converge at the poles, creating these chaotic vortices. But the exact mechanics of the double structure remain unclear. Some theories suggest it's driven by temperature differences or the planet's extreme atmospheric pressure, while others propose hidden wave patterns guiding its motion. What's even more puzzling is how stable it is. Earth's polar vortices come and go with the seasons, but Venus's has been observed for decades without significant change. This stability hints at deeper, unseen forces at work in the planet's atmosphere, forces we're only beginning to understand. Every mission to Venus, from past probes like Venus Express to future ones like Veritas, brings us closer to unraveling this enigma. With each new glimpse, we're reminded that even our closest planetary neighbor has secrets waiting to be uncovered. Next, we'll revisit one of the most debated cosmic visitors in recent memory, the interstellar object Oumuamua, and the fresh twists in its already puzzling story. The universe, it seems, never runs out of surprises. Now, let's turn our attention back to one of the most baffling visitors from beyond our solar system, the mysterious Oumuamua. This interstellar object, first spotted in 2017, didn't just pass through our cosmic neighborhood. It left scientists utterly perplexed with its strange behavior and unexplained features. From the moment it was detected, Oumuamua stood out. Unlike typical asteroids or comets, it had an elongated, cigar-like shape, stretching nearly 10 times longer than it was wide. But the real head-scratcher was its movement. Instead of following a predictable path dictated by gravity alone, Oumuamua accelerated slightly as it sped away from the sun, something comets do when their icy surfaces vaporize, creating a visible tail. Yet Oumuamua showed no signs of outgassing or a tail, leaving researchers scrambling for explanations. Some scientists suggested it might be a rare type of hydrogen iceberg, sublimating invisibly in sunlight. Others proposed it could be a pancake-shaped fragment from a shattered planet tumbling through space. And then, of course, there was the more sensational theory: could it be an artificial object like an alien probe? While most astronomers dismiss this idea, the lack of a clear natural explanation keeps the debate alive. Adding to the mystery, Oumuamua's trajectory didn't match any known solar system origin. It came from the direction of Vega, but by the time it reached us, Vega wasn't even in that spot anymore, meaning Oumuamua had been drifting through interstellar space for possibly millions of years before we spotted it. Despite years of study, Oumuamua remains an enigma. Was it a cosmic oddball, a fragment of an alien world, or something even stranger? With no new data since it vanished from view, the questions linger, reminding us how much we still don't understand about the visitors from the void. Next, we'll tackle another cosmic puzzle, the missing lithium problem, and why the universe seems to have far less of this element than our theories predict. The mysteries, it seems, are endless. Now, let's unravel another cosmic conundrum, one that challenges our understanding of the universe's very first moments. The missing lithium problem is a head-scratcher for scientists because, according to the Big Bang theory, there should be way more lithium out there than we've actually found. Here's the puzzle. When the universe was just a few minutes old, the extreme heat and pressure of the Big Bang fused protons and neutrons into the lightest elements, hydrogen, helium, and a tiny bit of lithium. This process, called Big Bang nucleosynthesis, left behind a predictable ratio of these elements. Hydrogen and helium match those predictions almost perfectly, but lithium. Not so much. Observations show only about 1/3 the amount of lithium that our calculations say should exist. So where did it go? One possibility is that lithium gets destroyed inside stars. As stars burn, their intense heat could break lithium apart, turning it into other elements. But even accounting for that, the numbers still don't add up. Another theory suggests that unknown physics in the early universe altered how lithium formed, leaving us with less than expected. Or maybe our measurements are off. Lithium could be hiding in places we haven't looked yet, like the cool outer layers of certain stars. The mystery deepens when you consider that this isn't just a small discrepancy. The missing lithium problem points to a gap in our understanding of cosmic chemistry, forcing scientists to rethink everything from stellar physics to the conditions of the infant universe. Next up, we'll shift our gaze closer to home to explore the eerie glow of the zodiacal light, sunlight scattered by mysterious dust in our solar system. The cosmos, it seems, is full of riddles waiting to be solved. Now, let's turn our attention to a celestial phenomenon that's both hauntingly beautiful and scientifically puzzling: the zodiacal light. If you've ever seen a faint, ethereal glow stretching up from the horizon just after sunset or before sunrise, you've witnessed this mysterious light firsthand. But what exactly causes it? The answer lies in sunlight bouncing off countless tiny dust particles scattered throughout our solar system. These particles form a vast, disc-shaped cloud that stretches along the same plane as the planet's orbits, called the ecliptic. When sunlight hits these minuscule grains, it scatters in all directions, creating that ghostly glow we call the zodiacal light. But here's the twist: we still don't fully understand where all this dust comes from. Some of it is likely debris left behind by comets and asteroids, crumbling as they journey through the solar system. Other theories suggest it could be the remnants of ancient collisions between larger bodies, or even dust drifting in from interstellar space. What makes this even more intriguing is that the amount of dust doesn't quite match our expectations. Observations show there's less of it than predicted, hinting that some unknown process, maybe the sun's heat vaporizing the grains or the solar wind sweeping them away, is slowly clearing it out. The zodiacal light isn't just a pretty sight, it's a clue to the hidden dynamics of our cosmic neighborhood. By studying it, scientists hope to uncover secrets about the solar system's formation and evolution, one scattered photon at a time. Next, we'll dive into another marvel of our solar system, the bizarre and perfectly geometric storm at Saturn's North Pole. The universe never runs out of surprises. Now, let's journey to one of the most striking and perplexing features in our solar system, Saturn's North Pole, where a storm unlike anything else rages in near-perfect geometric precision. Imagine a colossal hexagon, wider than two Earths stacked side by side, spinning steadily at the heart of this gas giant. This isn't some artist's rendering or a trick of the light. It's a real, persistent phenomenon that's baffled scientists since its discovery. What makes this hexagon so extraordinary is its razor-sharp edges and near-mathematical symmetry. Storms on planets, including Earth, tend to be chaotic, swirling messes. But Saturn's hexagon defies that expectation, maintaining its six-sided shape with almost unnatural precision. So how does a planet produce something so geometrically perfect? One leading theory suggests it's all about the way fluids behave under extreme conditions. Saturn is a gas giant, meaning its atmosphere is essentially a vast, turbulent ocean of hydrogen and helium. Laboratory experiments show that when fluids rotate at high speeds, they can sometimes form stable polygonal shapes like the hexagon we see. The planet's jet streams, racing at hundreds of miles per hour, might be carving out this structure like an invisible sculptor. But here's the real kicker: this storm isn't just a fleeting feature. It's been observed for decades, surviving Saturn's long seasons and dramatic atmospheric changes. That durability hints at something deeper, perhaps a fundamental property of how energy moves through the planet's atmosphere. Some researchers even speculate that the hexagon could be a kind of standing wave, a stable pattern created by the interplay of rotation and wind shear. And let's not forget the sheer scale of this thing. The hexagon's sides are each longer than the diameter of Earth, and its central hurricane boasts winds faster than any ever recorded on our planet. It's a reminder that the laws of physics can produce wonders beyond our everyday experience, if only we know where to look. As we peel back the layers of this mystery, we're not just learning about Saturn, we're uncovering universal truths about fluid dynamics, planetary atmospheres, and the hidden order within chaos. Next up, we'll explore another cosmic oddity that challenges our understanding of the universe's architecture. The cosmos, it seems, loves to keep us guessing. Now, shifting our gaze from the geometric marvels of our solar system to the vast canvas of deep space, we encounter another celestial wonder that defies easy explanation: Hoag's object. Picture a galaxy so perfectly ring-shaped it looks like it was drawn with a cosmic compass. Nestled in the constellation Serpens, this peculiar galaxy is a rare gem, one of only a handful of its kind ever discovered. What makes Hoag's object so fascinating is its nearly flawless circular structure. At its core lies a dense, spherical cluster of aging yellow stars, while surrounding it is a vibrant blue ring of younger stars, gas and dust. The two are separated by a dark, seemingly empty gap, creating a striking bullseye effect. It's as if someone took a conventional spiral galaxy and removed all the twisting arms, leaving only this pristine ring. So how does such a perfect ring galaxy form? One leading theory suggests a galactic collision, a smaller galaxy piercing through the center of a larger one, like a stone skipping across a pond. The gravitational shockwaves could have triggered star formation in a circular wave, leaving the central core untouched. Another idea posits that Hoag's object might be the result of a rare instability in a galaxy's rotation, causing its outer regions to collapse into this symmetrical ring. But here's the twist: Hoag's object shows no signs of a recent collision, nor any nearby galaxies that could have caused such a disruption. This leaves astronomers scratching their heads. Could it be the remnant of an ancient merger, its scars long faded? Or is there some other, yet unknown process that can sculpt a galaxy into such a perfect ring? Adding to the mystery, astronomers have spotted another, fainter ring galaxy lurking in the distance behind Hoag's object, a cosmic coincidence that hints these structures might be more common than we thought. Yet for now, Hoag's object remains a dazzling outlier, a reminder that the universe has a flair for the unexpected. As we marvel at its symmetry, we're left to ponder the forces that shape such celestial masterpieces. Next, we'll turn our attention to another enigmatic feature of the cosmos, one that challenges our very understanding of space and time. The universe, it seems, is full of puzzles waiting to be solved. Now, as we peel back another layer of the universe's mysteries, let's zoom in on one of the most baffling features etched into the fabric of space itself: the cosmic microwave background cold spot. Imagine the afterglow of the Big Bang, a faint microwave light that fills the entire cosmos like a fingerprint of creation. But within this uniform sea of radiation, there's a peculiar anomaly, a patch of sky colder than its surroundings by a margin that defies easy explanation. This cold spot, spanning nearly 1 billion light-years, was first detected by satellites like the Wilkinson Microwave Anisotropy Probe and later confirmed by Planck. At first glance, it might seem like a minor fluctuation, but the temperature difference is so stark that it challenges our understanding of how the universe evolved. According to standard cosmology, such extreme variations shouldn't exist. The early universe was too smooth and uniform for such a colossal dent to form naturally. So what could have caused it? One daring theory suggests the cold spot might be a bruise left by a collision with another universe, a multiverse echo. If our cosmos bumped into a neighboring bubble universe during inflation, the energy drain could have left behind this frigid imprint. Others propose it's a vast cosmic void, a region of space eerily empty of matter, stretching so wide that light passing through loses energy, creating the illusion of cold. Yet when astronomers searched for such a void, they found nothing large enough to explain the anomaly. Then there's the quantum physics angle. Some researchers argue that the cold spot could be a rare statistical fluke, a cosmic roll of the dice where random quantum fluctuations in the early universe amplified into a colossal cold patch. But the odds of this happening are astronomically low, leaving scientists torn between accepting an improbable coincidence or rewriting the rules of cosmology. What makes this enigma even more tantalizing is that the cold spot isn't just a temperature oddity. Some studies suggest it's also a region where the fabric of space-time might be subtly twisted, as if the universe itself is warped there. Whether it's a window into the multiverse, a ghostly void, or a quantum glitch, one thing is clear: the cold spot refuses to fit neatly into our cosmic models. As we ponder this chilling mystery, we're reminded that even the most precise maps of the universe still hold shadows we don't yet understand. Next, we'll unravel a phenomenon so counterintuitive it seems to freeze time itself, a quantum quirk that bends the rules of reality. Now, let's shift our gaze from the vast cosmic anomalies to something far smaller yet equally mind-bending: the strange behavior of particles at the quantum level. Picture this: you're watching a pot of water, waiting for it to boil. Common sense tells us that the more closely we observe it, the sooner we'll catch those first bubbles forming. But in the quantum world, the opposite happens. The act of watching can actually freeze a particle in place, as if time itself has paused. This bizarre phenomenon is known as the quantum Zeno effect, and it turns our everyday intuition upside down. The effect gets its name from an ancient Greek philosopher, Zeno of Elea, who famously argued that motion is an illusion. His paradox suggested that if you observe an arrow in flight at any single instant, it appears motionless, so how does it ever reach its target? While Zeno's logic was flawed in the classical world, quantum mechanics brings an eerie twist to his idea. Here's how it works. In the quantum realm, particles exist in a haze of probabilities, constantly shifting between states unless they're measured. But if you bombard a particle with rapid, repeated observations, you effectively trap it in its current state, preventing it from evolving. It's like flipping a coin but catching it mid-air over and over. It never gets a chance to land. Scientists first demonstrated this effect in the lab using atoms manipulated by lasers. By continuously measuring the atom's energy states, they found they could freeze them indefinitely, defying the natural tendency to decay or change. Some researchers even speculate that this principle could explain why certain unstable particles in nature last longer than expected, as if the universe itself is constantly checking in on them. But the quantum Zeno effect isn't just a curiosity, it has real-world implications. Engineers are exploring ways to harness it to stabilize quantum computers, where fragile qubits often lose their state too quickly. Others wonder if it could unlock new methods to control chemical reactions or even probe the boundary between quantum weirdness and our familiar classical world. Of course, this raises a haunting question: does reality only take shape when we observe it? The quantum Zeno effect blurs the line between the observer and the observed, suggesting that our very act of looking might shape the fabric of existence. As we grapple with this idea, we're reminded that the universe's smallest scales hold mysteries just as profound as its grandest structures. Next, we'll revisit a star whose flickering light has sparked debates about alien megastructures and the new clues that might finally crack its code. Now, let's turn our attention back to the stars specifically, one that's been baffling astronomers for years. Meet Kick 8,462,852, better known as Tabby's star. This isn't your average twinkling dot in the sky. Instead, it behaves like a cosmic light switch, dimming and brightening in erratic, unpredictable ways. Unlike most stars, which dim in regular patterns due to orbiting planets, Tabby's star drops in brightness by as much as 22% at times. a staggering amount that defies easy explanation. When it was first discovered in 2015, the star's bizarre behavior sparked wild theories, from swarms of comets to something even more extraordinary, alien megastructures. The idea was that an advanced civilization might have built a Dyson sphere, a hypothetical giant structure designed to harness a star's energy, causing the irregular dimming. While that possibility captured imaginations, scientists knew they needed more data before jumping to conclusions. Years of follow-up observations have both deepened the mystery and offered new clues. Dust seems to play a key role, with recent studies suggesting uneven clouds of cosmic particles could be scattering the star's light. But here's the twist: the dust doesn't behave like typical debris from comets or asteroids. It's finer, more uneven, and doesn't match any known natural phenomenon perfectly. Some researchers propose a catastrophic planetary collision, while others point to lingering remnants of a shattered moon. Yet the megastructure theory hasn't been entirely ruled out. While less likely, it remains a tantalizing what if in the absence of a definitive answer. What makes Tabby's star so compelling isn't just the mystery itself, but what it reveals about how we explore the unknown. Sometimes the universe throws us a curveball that challenges everything we think we know, and that's when science gets truly exciting. As we continue to monitor this enigmatic star, one thing is clear: whether the answer lies in cosmic dust or something even stranger, Tabby's star reminds us that the universe is full of surprises. Up next, we'll ponder the ultimate fate of the cosmos itself. Will it end in fire, ice, or something even more unexpected? Now, let's zoom out from the mysteries of individual stars and galaxies to confront the biggest question of all: what happens to the universe in the end? Scientists have theorized several possible fates for our cosmos, each more dramatic than the last. The first and most widely accepted scenario is the heat death, often called the Big Freeze. Imagine the universe expanding forever, stars burning out one by one until all that's left is a vast, cold, and lifeless void. Energy spreads so thin that no new activity can occur, and time itself becomes meaningless. It's a bleak but plausible ending, driven by the relentless acceleration of dark energy. Then there's the Big Crunch, a fiery counterpoint to the freeze. If the expansion of the universe slows and reverses, everything could come crashing back together in a cataclysmic collapse. Galaxies, stars, and even atoms would be compressed into an unimaginably dense point, perhaps triggering another Big Bang and restarting the cycle. It's a cosmic reboot, but the evidence for this scenario has waned as observations show the universe's expansion speeding up, not slowing down. But what if dark energy gets even stronger over time? Enter the Big Rip, the most violent finale of all. In this scenario, the force tearing the universe apart grows so powerful that it shreds everything: first galaxies, then solar systems, planets, and finally even atoms themselves. The universe wouldn't just fade away, it would be torn apart in a crescendo of destruction. So which fate awaits us? Right now, the heat death seems the most likely, but the universe has a habit of surprising us. Each of these theories forces us to grapple with profound questions about time, energy, and the very fabric of reality. And as we ponder the end, let's turn to another mind-bending idea. Could the universe be nothing more than a two-dimensional projection? That's the startling claim of the holographic principle, and it's up next. Now, let's take a step into one of the most mind-bending ideas in modern physics, the holographic principle. What if everything we see, touch, and experience in our three-dimensional world is actually just a projection from a two-dimensional surface? It sounds like science fiction, but some of the brightest minds in theoretical physics are seriously considering this possibility. The idea stems from black hole research. When scientists calculated the information content of a black hole, they found something bizarre. The maximum amount of information it can hold isn't proportional to its volume but to its surface area. In other words, all the data needed to describe everything inside a black hole could be encoded on its boundary like a cosmic hard drive. This led to a radical thought: what if the entire universe works the same way? If the holographic principle is true, then the three-dimensional reality we perceive might just be a shadow of a deeper, two-dimensional reality. Think of it like a movie projected onto a screen. The images appear three-dimensional, but they're actually coming from a flat surface. In this case, the screen could be the edge of the universe itself, and we're all just part of the projection. Some versions of string theory even suggest that the fabric of space-time itself is made up of tiny, vibrating strings, and their interactions on a distant two-dimensional surface create the illusion of depth. It's a wild concept, but if proven, it would completely rewrite our understanding of reality. Of course, this is still just a theory. No one has found direct evidence yet. But experiments with quantum gravity and particle physics are testing the idea, and if confirmed, it could solve some of the biggest mysteries in physics, like how gravity fits into quantum mechanics. So, is our universe just an elaborate hologram? We don't know for sure, but the possibility alone challenges everything we think we know about existence. And speaking of reality-bending ideas, let's wrap things up with one last cosmic mystery. What if our entire universe isn't just a hologram but a simulation? That's next. Now let's dive into the final and perhaps most provocative mystery on our list, the simulation hypothesis. What if everything around us, from the stars in the sky to the device you're watching this on, isn't real? What if it's all just an incredibly advanced simulation, like a video game created by a civilization far more sophisticated than ours? This idea isn't just the stuff of sci-fi movies. Some philosophers and scientists argue it's a legitimate possibility. The reasoning starts with a simple question: if advanced civilizations could create simulations indistinguishable from reality, wouldn't they eventually create countless ones? And if that's true, the odds that we're living in the one real universe might be astronomically low. Think of it like this: if future humans develop technology to simulate entire worlds with conscious beings inside, those simulated beings would have no way of knowing they're not in the base reality. To them, their world would feel just as real as ours does to us. So how do we know we're not in the same position? Some researchers even look for potential glitches in our universe that could hint at a simulated reality. For example, have you ever noticed how the universe seems to run on mathematical rules? Or how particles behave differently when observed, almost as if the simulation is optimizing processing power? These quirks don't prove anything, but they do make you wonder. Of course, not everyone buys into this idea. Critics argue there's no concrete evidence and the hypothesis is unfalsifiable, meaning it can't be proven or disproven with current science. But whether you find it plausible or far-fetched, the simulation hypothesis forces us to question the very nature of reality. And with that, we've reached the end of our cosmic journey through 50 of the universe's most baffling secrets. From dark matter to black holes, from quantum weirdness to the possibility we're living in a simulation, one thing's clear: the universe is far stranger and more mysterious than we could ever imagine. So, what's your favorite cosmic mystery? Drop it in the comments below, and don't forget to like, subscribe, and hit the notification bell so you never miss out on unraveling the universe's biggest enigmas. Thanks for joining me on this mind-bending adventure. Until next time, keep looking up. And just like that, we've traveled through 50 of the universe's most astonishing mysteries together. From the invisible grip of dark matter to the eerie silence of the cosmos, from black holes that defy physics to the mind-bending possibility that we might be living in a simulation, each secret we've uncovered reveals just how little we truly understand about the vast, enigmatic universe around us. Think about it: despite all our advancements in science and technology, we've barely scratched the surface. Every answer seems to lead to even bigger questions, and that's what makes space so endlessly fascinating. Whether it's the unexplained behavior of Oumuamua, the haunting emptiness of the Boötes Void, or the cosmic coincidence of the axis of evil, these mysteries remind us that the universe is far stranger than fiction. So now it's your turn. Which of these 50 secrets left you the most awestruck? Was it the eerie Great Attractor pulling galaxies toward it, or the bizarre quantum entanglement that connects particles across light years? Drop your favorite in the comments below. I'd love to hear which cosmic puzzle keeps you up at night. And if you've enjoyed this journey through the universe's hidden wonders, don't forget to hit that like button, subscribe, and ring the notification bell so you never miss out on unraveling more of space's greatest enigmas. Thanks for joining me on this adventure. Until next time, keep wondering, keep exploring, and never stop looking up at the stars. The universe still has so many secrets left to share.